What's up, geometry class? This is Mr. Wicklehouse, and today we're starting to talk about two-column proofs. Alright, let's get this show on the road. So what is a proof? What's a proof? Well, a proof is a mathematical argument that proves a statement through a series of statements that are accepted as fact. In other words, we're going to be using things that were proven before or that we know to be true, theorems or postulates, in order to prove some mathematical ideas. So much like in an argument, to prove a point, you must use relevant facts, not opinions, or you can't say just because. Okay? So a lot of times I'll ask you guys a question in class and somebody might say, well, that's just how it is. That's just math. Well, that is not a good enough answer. And when we do in these proofs, it'll allow you to answer those questions maybe a little bit more easily because you'll be able to think about it a little more. That being said, some of you have been asking me, why are we doing these conditional statements? This is so easy. And the lights just went out again on me. There we go. So what was the point of doing these conditional statements and stating the hypothesis and conclusion? That is so easy, Mr. Wicklehouse. Well, maybe it was, but I needed you guys to be able to say what the hypothesis and the conclusion were easily, because these hypothesi and conclusions are going to be used to kind of start off some proofs sometimes. Okay? So in proofs we have a given statement and a proof statement. These things come from the conditional statement. So if I have a conditional statement that states if 3x plus 2 equals 1, then x equals negative 1/3. We know from our work early on in this unit that the hypothesis here is 3x plus 2 equals 1 because that's the part with the if. And the conclusion is x equals negative 1/3 because that's the part with the then. Well, the hypothesis is what we would call the given in our proof. And the conclusion is what we're trying to prove given the hypothesis. So, I could rewrite this conditional statement right here, the if 3x plus 2 equals 1 and then x equals negative 1/3, as a proof kind of idea here. So given that 3x plus 2 equals 1, then I want to prove that x equals negative 1/3. That's as far as we're going to go with that right now because we have to learn about some vocabulary in order to prove this statement. Okay? So, we're going to call these your tools. You put them in your toolbox, in your mental toolbox, in order to be able to use these. In order to write these proofs, we need to be able to explain the steps it takes to do each thing. Here are the tools we will use to do this. So some of you may recognize some of these, and maybe you might have forgotten some of them. So we have this particular idea. It's called the addition property of equality. Okay, this is something we use all the time when we're solving equations. But in geometry, when we're writing these proofs, we have to be able to state addition property of equality. So if I have two numbers equal to each other, two different numbers, a equals b, then I can say that a plus c, or a plus another number, is going to be equal to b plus that number. Okay? So if a equals b, then a plus c equals b plus c. That's the addition property of equality. Subtraction property of equality. This is much like the addition property, except I'm subtracting that number. So if a equals b, then a minus c equals b minus c. Again, the multiplication property of equality is very similar to the previous two. So if a equals b, then a times c equals b times c. And then finally we've got the division property of equality. where we would say that if A equals B, then A divided by C equals B divided by C. Let's look at some examples of these so we kind of have an applicable idea of what's going on here. So here's an example of the addition property of equality. So if I've got 2x minus 3 equals 5. For this example, we need to add 3 to both sides as the first step to solve this equation, right? So I would say, like, in the next step of my proof, I would say that 2x equals 8. And that is because of the addition property of equality. Okay, because I added 3 to both sides. Easy, right? All right. Well, now let's talk about the subtraction property of equality. Same idea here. I've got the 2x, except this time I've got 2x plus 3 equals 5. Well, for this one, I have to subtract 3 on both sides as the first step. So I get 2x equals 2. And that would be because of the subtraction property of equality. Because I subtracted 3 from both sides. Multiplication property of equality. I've got, in this example, x divided by 2 equals 5. Well, in order to get the x by itself, I have to multiply both sides by 2, because to undo division, I have to do multiplication. So then I get x equals 10, and that's because of the multiplication property of equality. And I know that I'm abbreviating these, and when we go to write the proofs, if you want to abbreviate as well, I don't have a problem with that, so long as I can make sense of what you're saying, okay? Alright, so the division property of equality. So we'll go back to use this example earlier, 2x minus 3 equals 5. I added the 3 to both sides, given the addition property of equality, so then I got this 2x equals 8. Well, then I have to divide both sides by 2, and I get x equals 4. Well, that x equals 4, when I would write it, would be because of the division property of equality. Okay? So that's the first 4. And here's a few more. Alright. So this one is called the symmetric property of equality. So if A equals B, then I can flip it around through symmetry and say that B equals A. It's a pretty easy idea. You're just taking it and flipping it around. Transitive property says that if A equals B, or if a number equals some other number, and then that other number equals another number, then the first number we started with is equal to the number we ended with. So A equals B and B equals C, then A equals C. Alright. Substitution property. You guys have done substitution many times, like they'll say x equals 3 and so on and so forth, and you plug it back into another equation. Well, the substitution property says that if A equals B, then we can replace A for B in any equation. Okay, so I can plug A in for B, or B in for A, however you want to think about it. Distributive property. Well, this just means distribution. I'm just distributing through my equation here. So if A times the quantity B plus C equals D, then I could say that AB, or A times B, plus A times C equals D. They're the same. Finally, we've got the reflexive property, and for any real number A, then that number is equal to itself. You guys may feel like that makes no sense, or what's the point of that? It'll become more obvious in some later units when we do some more serious proofs. Okay? Alright. Let's do some examples of those, and then I'll be quiet, and you guys will be like, this video is finally over. Alright, so here's an example of the symmetric property. So, if I have 3 equal to x, then I can say that x equals 3. So I'm just taking this and I'm flipping it over. So I'm putting the x where the 3 is and the 3 where the x is. I just flipped it around. That's the symmetric property. Okay. Here's an example of the transitive property. So if I have this equation, c equals b plus 1, and I know that b plus 1 equals 3, then I can say that c equals 3, because here where the b plus 1 is, b plus 1 and b plus 1, I'm putting those together and cutting them out and putting 3 in for that spot. So that's an example of the transitive property. Okay, now the substitution property. Well, if I have 6x and that's equal to y, and I know that x equals 4, then I can substitute 4 in for x, which would then be equal to 24, which then would be equal to y. So substitution. Okay. Distributive property. 2 times the quantity x plus 4 equals y. Then I know when I distribute this that I get 2x plus 8 equals y. So if you ever do that in a proof, then that's the distributive property. Here's an example of the reflexive property. 5 equals 5. You guys are like, no kidding, Mr. Wicklehouse. 5 equals 5? Yeah, no joke. Well, we have to have a way to talk about that, so we came up with the reflexive property. Okay? So that's a lot of examples and vocabulary for you. You need to know these vocabulary words. So commit them to memory, because when you go and start doing your proof, you don't know these, it's going to be really hard for you guys to memorize this stuff. Alright? Well, that's all I've got for today, and I will talk to you guys later.